Model Diagnostics and Residual Analysis in Python. In this lesson, we will learn how to check how well a model fits data, spot problems, and improve predictions using residual analysis. You will use real-world time series data, explore important plots, and understand key ideas step by step. Let us get started. Running the cell now. After this lesson, you will know how to check a model using residuals. Ready? Before working, let us set up important tools. We are importing warnings, pandas, numpy, and matplotlib. This line tells Python to hide warning messages. It makes output cleaner. Pandas helps work with data tables, like Excel sheets. numpy can help with numbers and math. Matplotlib lets us draw charts and graphs. Running the cell now. Practice. Can you name a time you saw a simple line graph in real life? Let us load a real dataset. This one tracks plane passenger counts over time. We are loading the data from the web into memory. We tell pandas to turn the month column into real date values. We give easy names to the columns. Y for numbers, date for time. This applies the date type just to be sure. Now we set date as the row label so time works right. We print the number of rows and columns, so you see the size. Now, we view the first 5 rows as a sample. Running the cell now. Try, how are real-world time series different from random numbers? Let us see what the data looks like over time. We use pandas and matplotlib to draw a line of all passenger counts. We label the x-axis so people know it means dates. This one labels the y-axis so you know what number we count. This command pops up the plot below code. Running the cell now. Tip: visualization helps spot strange patterns right away. What are residuals? Residuals are the leftover parts after a model makes predictions. They help show what the model missed. If they look random, it is good. If there are patterns, we can do better. Running the cell now. Let us build our first model and look at its residuals soon. Now we make a simple model. It predicts each value using the average of the past 12 months. We create a new prediction column. Each value is the average of the past year, shifted so there is no cheating. We create a chart to compare the real values and the prediction. We draw the actual passenger counts. We draw the predictions with a dashed line so they stand out. This shows which line is which. Add a title to explain what the chart means. Show the finished picture below. Running the cell now. Notice places where the prediction misses real ups and downs. This is what residuals will help us analyze. Now let us see the actual errors. Subtract the prediction from the real value. This gives the error, or residual. Draw a new line chart of all the residuals. Our error line is purple so it stands out. Draw a line at 0 for easy reference. Add a title to remember what it is. Label the y-axis to show it is the error. Show the chart. Running the cell now. Are big errors happening all at once, or do they look random? Good models have random errors. Why plot residuals? Plotting residuals can reveal bias, missed patterns, or data issues. If you see shapes, trends, or repeating errors, you may want to try a better model. Running the cell now. Predictions do not exist for the first year. Let us drop those rows before checking errors. We create a new dataset without missing predictions. Now, we show the average of all errors. A good model has an average close to 0. We print how much the errors spread around the average using standard deviation. Running the cell now. Low spread and a mean near zero hint at a fair model. High numbers mean room to improve. A histogram helps us see how often each error size occurs. Let us plot one. Draw a bar chart of all error values, sorted into groups. Add a title for context. Label the x-axis for the error value. Label the y-axis for the count, or how often it happens. Now we see the chart. Running the cell now. A good model has errors mostly around zero, with few very big misses. Now let us check if errors depend on predicted values. We look for patterns. Draw dots with predicted values on the x-axis and errors up and down. Draw a horizontal line for reference at zero error. Explain what predictions are on the x-axis. The y-axis shows error sizes. Add a title to stay organized. Show the scatter plot. Running the cell now. If you see a funnel or curve, the model is missing something important. Model diagnostics, key questions. Are the errors random or do they show patterns? Are errors bigger at certain times or sizes? Did we miss seasonality or trends? Can another model do better? Let us test for randomness next. Running the cell now. Keep these questions in mind as you check your diagnostic plots. We want errors to be independent, not predictable. Let us check autocorrelation, which tests if errors repeat. Import a special tool to help check correlation over time. Create the autocorrelation plot for residuals. Add a title for meaning. Show the chart. Running the cell now. Tall bars away from zero mean errors are not random, so the model can improve. Many models assume errors are bell-shaped, or normal. A QQ plot checks this. We import a tool for statistics. This makes a special plot. If dots are close to the line, errors are normal. Add a title for context. Show the QQ plot. Running the cell now. If residual dots line up with the straight line, our model's errors are typical and expected. Let us see if a smarter model, called ARMA, gets better residuals. We bring in statsmodels, a library for classic models. Build an ARMA model with basic settings for this data. Fit the ARMA model to our time series. Get predicted values from the model. Calculate ARMA residuals by subtracting predictions from real values. Draw the error line for ARMA model. It is red for easy contrast. Add a horizontal zero reference. Title the chart. Add a legend to keep labels clear. Show the plot. Running the cell now. Are ARMA errors closer to zero? Changing models can reduce leftover patterns. Let us see both errors set side by side in one plot. Draw two overlapping bar charts so you can compare error sizes. Add both chart series with a little see-through effect. Label the horizontal axis. Label the vertical axis. Give the combined chart a clear title. Add a legend so you know which is which. Show the histogram. Running the cell now. Which model has errors closer to zero? The smaller the spread, the better the fit. Let us get interactive. Guess a monthly number from the chart, and we will tell you if it makes sense. This line asks you to type a number and hits enter. Print out what you entered. If you guess too high, tell you so. If your guess was smaller than any real value, you will hear about it. If the number is in the real range, praise the guess. Running the cell now. Try, what is the biggest passenger count you see in the chart? If you like this hands-on practice, give us a like and subscribe for more beginner Python lessons. Troubleshooting tips. If errors are not random, change models or add features. Always look at charts before trusting results. If predictions look behind or ahead, check your code for time shifts. Outliers can trick your model. Mark or remove them if needed. Missing values give bad errors. Use dropner if you see nams. Running the cell now. Remember, every chart and error is a clue to make a better model. Let us try another time series. Here we study shampoo sales using the same steps. Download shampoo sales data and set it up just like before. Download from the web as before. Parse the months into dates. Create a sequence of monthly dates starting at January 1901. Convert the month column to date-time format. Rename the columns to make code easy to read. Make sure dates look right to Python. Set dates as row labels. Predict each month using the average of the last 6 months. Calculate error by subtracting prediction from true value. Plot the shampoo model's residuals in teal for contrast. Draw a line at 0 error. Title the chart so you know what data this is. Make sure it all fits nicely. Show the final plot. Running the cell now. Try, do errors in shampoo sales look more random than airline passengers? What could cause any patterns? Let us check how good the shampoo model is and decide if it can improve. Print the average error size from the shampoo model. Print the standard deviation or typical size of error. If the error average is large, suggest a better method. If not, praise the model and encourage small improvements. Running the cell now. Tweak the window size parameter and see if the summary improves. Now let us make residual plots easier. Here is a shortcut function. This code defines a function that takes predictions and real values and draws a quick error plot. Subtract predictions from Y to get residuals. Draw the error line in navy blue. Add a light gray line at 0. Give it a custom title. Show the plot. This is how you use the new shortcut function with shampoo data. Running the cell now. You can use plot_resids anytime you need to check errors fast. Let us challenge you, pick your own window size and see how it changes the error plot. Ask you to type a number for how many months to average. Make predictions with your custom window size. Draw the errors quickly using your shortcut. Set the plot title to include your chosen window. Say out loud, was the spread of errors bigger or smaller? Test a few numbers and find what works best. Running the cell now. Try a few sizes for window_size and see if you can improve the model's errors. Recap. You learned how to check model fit using residuals. You saw that looking for random errors means your model is on track. You used simple models and a classic ARMA on real data. You learned to spot problems and fix them with new ideas. Keep practicing and let us know your questions. Running the cell now. Summarize this lesson for yourself in one sentence. Thanks for learning model diagnostics. If you found this lesson helpful, please like, comment, and subscribe for more Python tutorials. Happy coding! Running the cell now. Thank you for following along. Try diagnosing your own favorite dataset next.